Hello everyone. Welcome to all in this video lecture series of computer networks. My name is Deepak Aneja, Assistant Professor, ABES Engineering College. In this video, we will discuss about the Internet Protocol. Internet Protocol is the network layer protocol. It is host to host network delivery protocol designed for Internet. Host to host means there is a host computer. This is source and this is destination. In between, these are connected via various routers from source to the destination. So the network layer or internet protocol is used to deliver the packets from source host to the destination. So it's responsibility of delivering the packets from source to destination. So it is also called host to host network layer delivery protocol designed for internet. It is connectionless datagram protocol with no guarantee of reliability. No guarantee of reliability means this is unreliable protocol because it does not provide any error control and flow control mechanism. As we already studied in data link layer, the reliability will provide through the error detection or correction process. So this will not provide any error control process. Each IP datagram is handled independently and each one can follow a different route to reach to the destination. So the possibility of receiving out of order packet at the destination. So the reassembling is of the packets is done by upper layer transport layer at the destination. For this IP protocol, there are two versions of IP. IPv4, IP version of 4, and IPv6. Here we will discuss about the IPv4. So the Internet Protocol version 4 is the delivery mechanism used by TCP IP protocols. So here is the position in OS in TCP IP protocol suite of IP. In the below layer, there is host to network. Above this, there is internet. In this internet layer, there is IP protocol, ICMP, Internet Control Message Protocol, IGMP is Internet Group Management Protocol, ARP Address Resolution Protocol, RARP is Reverse Address Resolution Protocol. So above its internet layer, there is transport layer. Here is SCTP, Stream Control Transfer Protocol, TCP, Transmission Control Protocol, UDP, User Datagram Protocol. Above it is application layer. Application layer. Here is SMTP, Simple Mail Transfer Protocol, POP3, Post Office Protocol of version 3, FTP, File Transfer Protocol, Telnet, Terminal Network, SNMP, a Simple Network Management Protocol, BootP, Bootstrap Protocol, DNS, Domain Name Server, www, World Wide Web, HTTP, Hypertext Transfer Protocol. There are various protocols at application layer. So in the TCP IP protocol suite, here is the position of IP protocol. Now the frame format of IPv4. This is also called the header format. The size of header plus data. The total size from header and data is minimum 20 bytes to maximum 65536 bytes. The size of header is minimum is of 20 bytes and maximum is of 60 bytes. The remaining is dead. So the frame format, this header contains all the information. This is of 32. The first field is of version. This is 4-bit field. Next is header. This is also a 4-bit field. Now the types of services. This is 8-bit field. Next is total length. This is 16-bit field. Now next 16-bit field is of identification. Identification. Now here 3-bit field is of flag. This is 3-bit field. Now here is fragment offset. This is 13-bit field. Next 8-bit field is of TTL, time to live. Next 8-bit field is of protocol. Here is 16-bit field is of header checksum. This complete 32-bit field is of source address. Then 16-bit field is of destination address. After that, there is of variable length option field. This is the IPv4 header format. Now, one by one, we will discuss the each field in details. Now, first field is of version. This is 4-bit field, which defines the version of IP. So this is the version is IPv4. So the value of this field is 4. Now next field is header length. This is internet header length. This field defines this field defines the length of header. So the minimum length of size of header is 20 byte and maximum 60 bytes, including option field. Including option field. Next is type of services. Type of services. This field allows the host to tell the subnet what kind of services it wants. The various services it offers are this is 8-bit field, which includes first 3-bit fields represents the precedence. Next, this is for minimize delay. These are the type of services D T R C. This is also the principal. So here, this is the D stands for minimize delay. P stands for maximize throughput. R stands for reliability. And C stands for minimize cost. Minimize cost. So this type of services bits explain the which services the subnet wants. For this 4-bit 000 value stands for the normal, that is default. 0001. If this bit field is 1, then it will represent the minimum post. Now 0010 stands for the maximize reliability. Then 0100, this represents the maximize throughput. And 1000 will represent the minimize delay. So these types of services provided by the subnet it defines. Next field is of total length. Next field is of total length, which includes the size of header plus data, which includes the size header plus data. Next field is identification. Next field is identification. So identification field tells the datagram is originating from the source host. When a datagram is fragmented, the value in the identification field is copied into the all fragments. The identification number helps the destination in reassembling the fragments at the destination. Next field is flag. Flag is of 3-bit field. Flag is a 3-bit field. This is 1 bit, 1 bit, 1 bit. First is unused. This is not used. Next field is DF. DF stands for do not fragment. If this bit is 1, it represents then the machine should not fragment the data. If this is 0, then machine should fragment the datagram. Next field is MF, more fragment, more fragment. If this bit is 1, it means that the datagram is not the last and only the fragment. If this bit is 0, it means it is the last or only the fragment. Next field is fragment offset. Fragment offset. Fragment offset is of 13-bit field, which defines, which shows the relative position of the fragment with respect to whole datagram. Now we will see how to calculate the fragment offset value in this. 0000. And last byte that we have delivered is 399. Total 4,000 bytes we want to deliver. Suppose we want to create the three fragments of this datagram. So the size is of first fragment is of 1400 bytes. Second fragment is 1400 bytes. And the remaining third fragment is of 1428 minus 4000. 12. So the how to calculate the offset value for this first fragment is that is initially it represents the value 0000. So the offset value is 000 divided by 8, it is 0. So in this field, this is 0. And total size of this fragment is of 1400 bytes, 1400 bytes. So the last pointer is of 1399. Now the next fragment starts from 1400 and last 2799, total 2800. So the offset value of this second fragment is 1400 divided by 8. This is 175. So the offset value for this second fragment is 175. For this third fragment, the first value is of 2800 and the last represents a 3999. The offset value we will calculate as 2800 divided by 8. This is 350. This is the offset value of third fragment. So the fragment offset value for the first fragment is always 0 or the field is of 13-bit wide. So the offset can be from 0 to 8191. Fragments are specified in units of 8 byte, which is why fragment length must be a multiple of 8. Through this, we can calculate how much fragments, how much data is to be delivered at the destination. We will calculate through this offset value. Suppose here is the value is 175 into 8. This is so before that 1400 bytes we already delivered. Already delivered at the destination. Next field is TTL. Next field is TTL, time to live. So it will define the packet lifetime. This is time is in seconds and maximum lifetime of a packet is 255 seconds. Maximum lifetime is 255 seconds. Next field is protocol. Protocol, this field defines the which protocol uses the services of IP layer, such as upper layer is TCP, UDP, and etc. In this protocol field, in network layer, there is transport layer. So which protocol uses the service of this network layer IP? These are SCTP, TCP, and UDP. So the value defines in this field is one defined for ICMP protocol, two defines the IGMP, Internet Group Management Protocol, six defines the value of TCP, 17 value defined for UDP, and 89 is for OSPF, Open Source Shortest Path First. So this field, protocol field defines The which protocol uses the services of IP layer, such as TCP, UDP, SCTP. Then is header checksum. So we already told that IP is unreliable protocol because there is no checksum, there is no error detection method. But this field is header checksum. Header checksum stands for this is used to determine the error detection for this header only. For this header only. Next is 32-bit source address, and next field is 32-bit destination address. Next is option field. Options are used for network network testing and debug. So this is the frame format of IPv4.